Welcome to this video, From Analog Craft to Synthetic Biology's Design Across Time. I am Professor Thomas Spiegelhalter, PhD, from the Florida International University in Miami, Florida, currently working at the FIU World Center in Genoa, Italy. Thank you for having me here at the Conference on Design Principles and Practices at the University of Sapienza 2026. Our research question explores how architectural epistemologies evolve across time, spanning from analog craft to digital computation and into the future of AI and synthetic biology. We chart the epistemic transitions in architecture from ANALOGUE craft starting in 1974, when I enjoyed the Venice Pro Venetia Viva stipend by the UNESCO as a sculptor in Venice, Italy, adapting throughout all the changes of tools, workflows, and techniques of today in 2026 and beyond. This timeline shows the shift from analog craft to the digital transition, culminating in AI and synthetic biology. This complex diagram illustrates the history of CAD and building information modeling, emphasizing the vast network of companies and data that underpins our digital design tools. It also touches upon the 1990s in Berlin, how former architects of the University of the Arts, the artists of Art plus Com with Professor Joachim Sauter and a hacker, invented a new way to see the world. Years later, they reunite to sue Google for patent infringement on their algorithm, which is featured in the billion-dollar code Netflix movie series. In addition, the slide reminds that software developments always are interconnected, with the military-industrial complex's influence on defense spending and foreign conflicts for profit. Design must be viewed as a temporal responsibility, moving us beyond mere sustainability to full regeneration. This shift is critical to address the Anthropocene challenges, such as pollution and the climate crisis. My ongoing work, dating back to 1986, focuses on data-driven hybridization of scientific knowledge and global design research, as seen in projects like Under the Sun and various applied research initiatives. This image highlights my early work, the Gravel Pit Architecture projects, conducted between 1989 and 1999, focusing on unique site challenges and material engagement. To reiterate the core inquiry, how do architectural epistemologies evolve? We trace this evolution from analog craft through digital computation to the emerging field of AI and synthetic biology. Our methodology involves longitudinal research spanning 1974 to 2026, combining archival and built projects, practice-based design research, and tool ethnographies. This collage illustrates the breadth of our longitudinal research, showcasing carbon-neutral design projects, archival records, and built works that inform our understanding of design evolution. We delineate three major design eras: analog craft, the digital transition, and the era of AI and synthetic biology. Analog craft involves direct interaction with materials and physical construction, emphasizing tactile knowledge and manual skill. Craft remains vital because it provides learning through error, valuable material feedback, and builds embodied intelligence. This image illustrates the focus on material engagement and intuitive skill that defines analog craft. Hybrid workflows integrate sculptural intuition with algorithms, facilitating robotic fabrication and the creation of complex 3D printed structures. An example of a hybrid workflow project is the design for post-industrial infrastructures, which utilized AI and generative growth algorithm design and neural CAD, earning the SARC 2023 Architecture Award for one of the first 50-meter 3D printed steel bike and pedestrian bridge in Duisburg, Germany. These complex diagrams show the integration of digital tools, parametric modeling, and structural optimization that characterize our current design practice. The third era, AI and synthetic biology, involves machine learning design systems, autopoietic architecture, and the use of bioscripted materials, also known as engineered living materials. We are moving from bionics towards biointegration, seeing nature as a collaborator. This includes using living materials, developing metabolic architecture, and creating carbon-positive systems. Addressing the climate imperative requires design across time, focusing on challenges like sea level rise and the energy food-water nexus, using AI-driven climate design for resilient infrastructures. This slide further illustrates the importance of integrating technology and biological systems in future architectural solutions. Visualizing complex systems and their interaction is essential for designing resilient infrastructure in the face of climate change. The adoption of biointegration techniques promises architectural solutions that are inherently sustainable and regenerative. Developing bioscripted materials allows us to grow our buildings, minimizing construction waste and embodied energy. This image emphasizes the seamless connection between digital models and real-world implementation through advanced fabrication techniques. The challenges posed by the Anthropocene demand radical shifts in how we approach design and construction. Designing for metabolic architecture means creating structures that can actively engage with and adapt to their surrounding environment. Achieving true regeneration requires moving beyond mitigating harm to actively restoring ecological balance. The confluence of AI, computation, and biology provides unprecedented tools for addressing global challenges. In September 2021, the Italian Pavilion at the Venice Biennale hosted a pivotal panel discussion on synthetic biology for carbon-positive architecture. Curated by me, the conversation brought together visionaries Andrew Hessel, Mitchell Joachim, and Rachel Armstrong to explore how architecture must evolve from shaping inert materials to programming living functions. The panel's core message is clear. Carbon-positive design is not simply a material choice, but a metabolic contract. Cities must operate as closed-loop organisms, where waste becomes a resource and biology is treated as a powerful, ethical collaborator. From negotiating with microbial co-occupants to embracing distributed agency, the future of resilient design lies in circularity, not optimization, as a direct response to the urgent warnings written in rising waters and sinking ground. We must prioritize resilient urban planning and design to protect communities from the inevitable impacts of climate change. This image underscores the need for green-blue adaptive infrastructures within the urban fabric. Carbon-positive design is a metabolic contract, not a material choice, requiring cities to function as closed-loop organisms. Waste becomes resource, biology an ethical collaborator. By negotiating with microbial co-occupants and embracing distributed agency, resilient design prioritizes circularity over optimization, answering the urgent warnings written in rising waters and sinking ground. Our research advances biointegrated architecture through real-world applications, like the 20-hectare Grande Calusa project in Fort Myers, Florida. This design embraces the reality that microbiomes are invisible co-occupants of live work environments, demonstrating that holistic, biomass-based design must actively coexist with these living systems. The complexity of these systems requires interdisciplinary collaboration between architects, scientists, and engineers. This slide outlines my long-standing academic research and experimentation focus on biologically inspired design, computational sustainability, and carbon-positive coding, which I've been teaching for decades across Germany, Japan, and the United States. In conclusion, design must evolve into a practice of long-term, multi-species stewardship rooted in participatory democracy and a deep ethical commitment to all forms of life. This is not simply about building for humans, but about fostering holistic coexistence within biomass systems, where architecture, society, biology, and technology collaborate as equal participants. By moving decisively beyond anthropocentrism, we honor the intelligence of living systems and ensure that regenerative futures are not just sustainable, but just, inclusive, and resilient for generations to come. Thank you for your attention. Let's have questions and discussions.